The value of enzymes in an inoculant. Questions to ask. Source of the enzymes. What substrates do the enzymes work? What research is available? What does the research prove? What does the company claim the enzymes do? Source of the enzymes. It is important to know that there are multiple sources of enzymes in inoculants. Bacteria are included in almost every inoculant. The goal of these bacteria is to ferment/degrade sugars, produce acids, and lower the pH of the fermented crop. Typical sources of enzymes in inoculants are either of bacterial or fungal origin. What substrates do the enzymes work? Bacteria produce enzymes to break down substrate, take it into the bacterial cell, and ferment it to an end product, which is typically an acid, lactic acid, acetic acid, etc. So, it would be true that all bacterial inoculants contain or produce enzymes. However, different bacteria produce different enzymes, and these enzymes are fairly specific for the substrate on which they work. An example, an amyloleic enzyme amylase works on amylose, starch, and has no activity on cellulose. So, the question that should be asked is specifically what substrates in the crop should the enzymes work. The typical bacteria in inoculants have no activity on the structural carbohydrates of the plant, cellulose, and hemicellulose. Silage Pro products with the proprietary enzyme pack. The enzyme pack in the Silage Pro line are added to the bacterial pack and formulated to degrade plant cells. The source of the enzymes is from selected strains of fungal organisms. Uniquely, the enzyme pack in Silage Pro also breaks down the plant cell wall. When the plant cell walls are broken down, fermentable sugars are released from within the lumen, inside the cell. Also, when these cell walls are broken down, it allows for greater ruminal bacterial attached and degradation when fed to the animal. More than just an inoculant. The enzyme pack not only helps to release plant sugars for the lactic acid bacteria to use to rapidly lower the pH, but also improves NDF digestion, fiber. So, the uniqueness of Silage Pro is getting a good fermentation and also improving the digestion when fed. Research-proven benefits. Tom Kilser research showed that Silage Pro improved NDF-D30, 67.05B versus 63.125A, over control. This nearly 4-point improvement means more energy from the fermented crop. It is interesting that this was done with BMR sorghum, which is already very digestible. The sugar content of the silage was also higher for the Silage Pro treated forage, 9.78B versus 6.83A. This means that the sugar then is available to the rumen microbes for growth and VFA production. Physical fill. Much research has now been done looking at rumen pool size and how important rumen fill is on intake and performance. There are several measures, but one would be from Miner Institute that suggests a high-producing dairy cow can consume about 0.48% of her body weight of UNDF-240. In the Kilser study, he showed that the UNDF-240 of the forage treated with Silage Pro was 10.5 compared to 12.6 for the control. Example: a high-producing cow weighing 1,500 pounds can eat 0.48% of her body weight equals 7.2 pounds. So, she could eat over 10 more pounds of the treated silage. Zahardini showed an improvement in NDF disappearance of 27.80 versus 23.29 at 16 hours when silage was placed in nylon bags in the rumen in situ. Similar to the Kilser work, this 4-point improvement in NDF digestion should produce the energy equivalent of 2.5 pounds of fat-corrected milk. Dry matter recovery. They also showed nearly a 9% improvement in dry matter loss of control. Muck reported that enzymes improved dry matter recovery up to 7.5% on average. So remember, when picking an inoculant, they aren't all created equally.